Hi everyone, I am Dr. Vs from EC Department, SNS College of Technology. Here we are going to discuss the topic Design for Testability and Built-in Self-Test. So this is the outline of this video. So VLSI IC or VLSI chips are nothing but an element. So that is consisting of billions of transistors inside it. So that is called as a VLSI chips. So we need to test each and every IC before it is sold to or before it bringing to the market. So that is the main reason behind it. So why testing is important? So if it is tested while manufacturing, so then the cost, the repairing cost or time, everything will be saved. So that is the main reason. So detecting errors before chips reach customer, ensuring reliability are some main reasons. So here we are going to discuss the design for testability and built-in self-test, which are the main essential technique in this testing approach. So what is the need for testing? So we can have different issues like manufacturing defect, aging effect, functional correctness, etc. So everything should be overcome before giving it to the market. So that is the main reason why we need to go for testing. Types of VLSI testing. So here as mentioned in the previous slide, we need to go in depth for testing. So based on the output or based on the components or based on the connectivity, everywhere we need to test. So that will be classified as manufacturing test, functional test, parametric test and system test. Manufacturing test represents the finding out the defects from fabrication process itself. So that is called as manufacturing test. And functional test represents so how the outputs are obtained. So whether the expected outputs are obtained from the given inputs. So that is identified with the help of the functional test. Parametric test discusses about the various electrical parameters like power, voltage, etc. And then system test, by giving different random inputs, we are testing the circuit. So that is called as a system test. So everything is necessary here before the IC is finalized. So manufacturing test principles. So what are the main cause of the faults? So it starts with stuck at 0 or stuck at 1, bridging fault, delay fault. So these are the different faults that may occur frequently in the ICs. So and then coming to the automatic test pattern generation, the software generates input vector to detect faults. So by generating different random input values and given to the circuit that is inside the IC and checking whether the output is based on the estimation or it is deviated from the estimated output. So if it is deviated, then it is a wrong value. If it is accurate, then it is a correct. IC is working correct. So that is the use of the automating test pattern generation. Design strategies for test. So what are the plans we have to test the IC? So to test the IC, we have scan design, boundary scan, test compression and design rule. So scan design represents we are connecting any shift registers additionally inside the sequential circuit like flip-flop and checking its functions, whether it is working in a right way. So and then boundary scan, using the JTAG cable, we are connecting the system with the kit and we are checking the circuit. So that is using the boundary scan. And test compression reduces the test data and time. And design rule tells about the controllability and observability. So coming to the design for testability, DFT, so it is the very efficient method when comparing to the conventional testing methods. So it reduces the test time. Okay. And common DFT features like extra test inputs and outputs, scan path for internal flip-flops, insertion of observant points. So extra test inputs and outputs. We need to test the IC by giving all ranges of input so that we can tell the IC is reliable. So that is the extra test inputs and outputs. Scan path for internal flip-flops. So that is, we are connecting the shift registers additionally, and we are checking whether the sequential circuits are functioning perfectly. So the main advantage of using DFT is nothing but faster testing, higher fault coverage, and lower cost of production. So this is the time for activity. And coming to the built-in self-test. So the chip tests itself using on-chip hardware. Okay, so this is the very efficient method as like DFT. So the main components inside this built-in self-test technique is test pattern generator and output response analyzer, so Bist controller. So these are the key elements so which performs the built-in self-test. And the advantage of doing built-in self-test is nothing but reduces the need for expensive external testers. Okay, so in VLSI, if you are going for even any IC production or any mode of testing, so everything is costly. So that is reduced with the help of this built-in self-test method. So allows at-speed testing. At-speed testing represents whether the output is obtaining in time. So that is calculated by using the clock signal, by giving input along with the clock signal. So that is called as allows at-speed testing. And then enables in-field testing, so like cars or any aircraft or medical devices. Types of Bist. So this built-in self-test is classified as memory Bist, so which tests the memory elements, and logic Bist, which tests the combinational or sequential circuits, and system Bist, which checks the overall circuit. Example, car engine control unit self-test before ignition. So real world application. So here by using this testing method, we can go for smartphones and automotive electronics and servers, CPUs and consumer devices. So in this video we have seen about what is the need for testing and what are the types we are having in testing, and we came to the assessment part here. So why is testing essential in VLSI circuits? To detect manufacturing defects and ensure reliability. So which of the following is a common fault model used in manufacturing test? So all of the above. Which standard is widely used for board level testing? So JTAG is the right answer. Which type of Bist is specifically designed to test memories like SRAM and DRAM? So memory Bist is the right answer. So thank you. That's all about this video. We can join in the next video. Thank you all.